Alright, I'm going to try to make a new video here for my lesson on compounds. I do have one already from the last semester, but it didn't involve Lewis diagrams. And Lewis diagrams are a much easier way to represent atoms. If you recall, right, we have two ways in which we can draw our atoms. We have Bohr diagrams, and we have Lewis diagrams. Let's just do a quick little reminder here. Let's take a look at our periodic table here, and let's draw a Bohr and Lewis diagram for sulfur. All right. So remember, a Bohr diagram, right, will have all of the orbits. The first orbit will have 2, the second orbit will have 8, and in this case, the third orbit will have, remember, we go up to the group number 6, 6 electrons in it. All right, so let's go back to our page here. And so if I'm going to draw sulfur, I need to know how many protons are in the nucleus. I forgot to look at that. 16. It looks like it's 16. Right? Remember, 16 protons in the nucleus. So if I draw a sulfur as a Bohr diagram, right, I'm going to draw a circle plus 16. And in the first orbit, I'm going to put 2 electrons. And in the second orbit, I'm going to put 8 electrons. Remember, they're kind of like bedrooms, and they don't want to share unless they have to. And in the full orbit, they all have to share. And in the third orbit, remember, we're in group 16, which means I am only going to put 6 in the outer orbit. 1, 2, 3, 4, 5, 6. All right, and that's a Bohr diagram. That took a lot of effort. We had to put a lot of orbits in there, and we had to put a lot of electrons in there. But remember, for the Lewis diagram, I just need the symbol in the center, S, and then I just need the outer electrons, those outer 6. 1, 2, 3, 4, 5, 6. And that is a lot easier to draw, and it's a lot easier to explain bonding, all right, making compounds. Because as you can see here, sulfur has 2 electrons that don't have any pairs. And sulfur will react so that they can pair up and fill that outer shell, right? All right, so let's throw all of this stuff, or let's erase my chalkboard here. Let's see if this works. Erase my chalkboard. Beautiful. That works like a charm. Missed a piece. Let's get rid of that. All right, and let's now get ready for the note. So I'm going to do the note a little differently here using a Jamboard. So today's lesson then is on compounds, all right? So there's my first slide if I were doing it as a PowerPoint. And I'm not going to wait for you to write things down. I do want you to write things down, but you can pause the video and write down what you need to write. Ignore that date. That's the old date when I did it last semester. So anyway, there's the title page, compounds, and I'm now going to throw that in the garbage. And let's look at number 2. So slide number 2, compounds. Now we've already talked about compounds. And compound, and I'm going to change my color here of my pen. Come on, pen. Let's go to white. Excellent. So they're a pure substance that's made up of 2 or more different atoms bonded together. A molecule is the smallest piece that can be made up of 2 or more atoms bonded together. So we can have something that we would call, say, a water molecule, H2O. All right, there you go. They're bonded together. But we could also have something like some salt, NaCl. And again, those are 2 different atoms, and they're bonded together to make what we call a compound. All right. So let's compare that and contrast that with what we know as being an element. So again, I'm going to throw this. Whoops. Got to grab all this stuff here. Let's grab all this stuff here. Let's get rid of it. All right. So now we've got element. So remember, an element is the simpler piece. All right. So an element is a pure substance that's made up of only one type of atom. One type of atom. And that's what we find on our periodic table. There's all of our atoms. They're made up of one type of atom, and it is an element. So an example of an element, well, we just looked at sulfur, all right, S. Right, there's an element. I can pick any of them off of the table. H, hydrogen is an element. Iron, Fe, etc., etc. All right, so those are our elements, and the smallest piece of an element is an atom. Okay, let's take that and get rid of that. Awesome. Let's expand that. Okay. So let's now talk about our different types of compounds. We have two different types of compounds that we can have. So we have something called an ionic compound. So in an ionic compound, a metal atom, all right, so that's the guys on the left, transfers or gives its outer electron to a non-metal atom, the guys on the right. All right, and this results in having a full outer shell. And remember, that's what atoms want to have. They want to end up with 8 electrons in their outer shell. All right, except for hydrogen. Hydrogen only needs 2. Okay. All right. So that's what an ionic compound is: a metal with a nonmetal. Just a reminder. Our metals are our guys over here. So these guys like to give their electrons away. And our nonmetals are these guys over here. These guys like to have electrons gained so that they can get a full outer shell. So let's go back and take a look at an example. All right, let's get rid of our stuff. Beautiful. And let's expand that. All right, so whoops. Let's move this up. Whoops. Slow down. Element, ionic. So let's do an example here. So the first example I'm going to do is a sodium getting together with a chlorine. All right, so let's take a look back at our periodic table. So remember, sodium is over here. It is in group 1, which means it has only one outer electron, 1 dot. Chlorine is over here. It's in group 7 or 17, which means it has 7 electrons in its outer shell. So let's draw that up. So sodium, Na, 1 dot, is going to get together with a chlorine. Remember, 7 dots. 1, 2, 3, 4, 5, 6, 7. Now notice, chlorine has 1 electron by itself, and sodium has 1 electron in its outer shell. So what happens is that sodium, we'll change the color just so that you can see it, will give its electron to the chlorine so that the chlorine can have a full outer shell. Now don't forget, sodium also has a full shell underneath its outer shell, right? Remember, it is in group 3, which means it has 2 and 8. So when it gives that one away, it also gets a full outer shell, which is what it's trying to get. All right? So in the end, let's turn that back to white. In the end, what do we get? We get an Na that now has a plus charge because it's given away its electron, and we've got a Cl that now has a negative charge because it's gained an electron. All right? And now they are both full. So both of these are full. They both have full outer shell. 8 electrons. All right? And that's what we call an ionic compound. When the metal gives away its electron to the non-metal. Excellent. Let's do another example. I'm going to get rid of this, like we know how. All right. Excuse me. Element, example. All right, so let's do one more example of these. All right, so let's take a look at magnesium and chlorine. So, magnesium. Magnesium is in group 2. All right, that means it's got 2 dots. What was the other atom? Magnesium and chlorine. We've seen chlorine. Chlorine is in group 7. 7 dots. So let's draw that out. So magnesium. Magnesium. Mg. 2 dots. Chlorine. 1, 2, 3, 4, 5, 6, 7. Uh-oh. It looks like this isn't going to work very well. The magnesium can give 1 to the chlorine, and now the chlorine is full. That's going to leave an extra 1 for the magnesium. Well, no problem, because in a chemical reaction, there are billions and billions of atoms. So we'll just use a second chlorine, which means that 1 of the magnesiums can go to there, the second magnesium can go to there, and I'm just going to end up with 2 chlorines. That's fun. So, in the end, I'm going to have a magnesium. It's given away 2 of its negative charges, which is going to make it plus 2. And I'm going to erase some of this stuff here from the last time. There we go. And then I'm going to have 2 Cl's, Cl, that now have 8 dots around them each. Oh, that's a bad picture of 8 dots. Each of those now is minus 1 because they've gained a negative charge. Minus 1. Excellent. Good. That's what we call magnesium chloride. Excellent. So those are ionic compounds. They're made up of, again, just to stress, they're made up of a metal getting together with some non-metals. And they all end up with full outer shells. All right, cool. Let's talk about, let's get rid of that. Let's grab up all of this writing and get rid of that. Okay. Let's move on. We've got one more type of compound I want to talk about. I want to talk about something called molecular compounds. They're slightly different. Molecular compounds are formed when, I've got some writing I still got to get rid of. I apologize. Let me get rid of that. Oops. Stop that. It's not going to let me. Hold on one second. That's already gone. Let's grab up some of this old writing. Get rid of it. Because it's white, it's hard to see. Let's try this again. Let's see what we got. Molecular compounds. Beautiful. That's better. 2 or more nonmetal atoms. So 2 or more of the nonmetals. The nonmetals, remember, they're on the right. So when we got 2 or more of these guys coming together. No more of these. Just these guys. 2 or more nonmetals share their electrons. And in the end, because they're sharing, it results in everybody having a full outer shell. All right. That's called a molecular compound. Okay? Now, so we've done 2 types. We've done a metal with a nonmetal. It's called ionic. And now we're going to do 2 nonmetals. That's called molecular. 2 metals, we've already talked about that earlier on. If I have 2 metals together, that's called an alloy. And that's not a compound, that's a mixture, if you remember. It's like a solution. Okay, so let's do some examples. Let's get rid of that. Again, you can pause the video if you want to write it down. Let's move up. Let's do our example here. Let's keep going. Molecular compound. And let's deal with some water. Okay? Okay, let's draw some molecules of water. So we know that water is made up of H2O, which means I need two H's and an O. Well, if we take a look at the O, it's in group 16, all right? 6 electrons. H is in group 1, 1 electron. So each H has an electron. Each O has 6. Instead of giving, these atoms share their electrons. All right? So they get really close together and they do this. 1, 2, 3, 4, 5, 6. The hydrogen gets really close to it, and the hydrogen gets really close to it. So this is interesting. This means that the oxygen now can get 8, and the hydrogens can get 2, but they don't give them away. They just get close and they share them. The way we draw this in chemistry is we keep these lone guys, but this pair right here we draw as a line. And that's what we call a chemical bond. All right? And so that means this is our water molecule. Okay? That's our water molecule. That's fun. So they share, they form these bonds. Let's do one more example of this. Let's throw this into the garbage. There's the trash. Let's expand that out and get my last note here. All right, let's do this one here. Okay. So, oxygen gas that we breathe in the air is actually made up of 2 oxygen atoms. I've got an oxygen atom that's like this. And notice those particular electrons are by themselves. I've got another oxygen atom like this. And now they're going to get together and they're going to share like this. They're going to share like this. So when they get together, it's going to look like this. 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 4. And then again, you can see each oxygen atom has 8 because they've snuggled up together to form an oxygen molecule. Again, the way we draw this in chemistry, oops, where'd my dots go? There we go, 3, 4. Again, oxygen, 3, 4. We draw now 2 lines in there to represent that. That means oxygen gas is O2. It's 2 oxygen atoms bonded together. Okay. I've got a little more to talk about here. I want to talk about counting atoms, but I'm going to put that into a different video so that you can then take a break and you can watch it later. Okay, that's that.